Hello world, you're welcome to lesson 1 of the journey that's becoming a computer programmer. In this lesson, we're going to look at the basic elements of C++. Before you continue with this tutorial, this lesson requires that at least you have an idea about hardware and software components of a computer, about information processing cycle. That's how the computer processes information. Part of the CPU, that's the central processing unit, said that you look at the arithmetic and the logical unit, how information is sequenced and being processed by the computer. You can also read these from the textbook 4, chapter 1, page 1. It talks about hardware and software components of a computer, a bit about the information processing cycle, and part of the CPU. So let's look at this lesson's objectives. By the end of this lesson, you should be able to define at least 10 basic terms associated with C++. Write a simple C++ program. You're going to have your first taste of C++ program. You should be able to state and explain at least 10 data types in C++. Right. So the first thing I would like us to define here is analog and digital signals. We use computer in our everyday life, at workplace, home, everywhere. We use it to play games, compose and store our documents. In basic terms, we define a computer as an electronic device that accepts input as data, processes it into information, output this information, may store and communicate that information. But the question is, how is the computer able to do all that? What kind of language does it use to do all that? Well, you might guess. Since the computer is an electronic device, it means that there are electrical signals that runs through it, and this is what the computer uses to process the instructions we command it. And these electrical signals, there are two types. These are the analog and the digital signals. So what are they really? The analog and the digital signals, what are they really? Now, the analog signal is in a form of wave. You can think of it as a continuous wave that varies in quantities with respect to time. Think about the thermometer. Okay, see the analog thermometer that we have in the hospitals. You go to hospital, they put it in your armpit, and then as and when the heat increases, it causes the mercury in the thermometer to rise, and as it rises with time, it increases whilst the heat is increasing, and then the demarcation and the thermometer is used to pick the readings of the temperature of the patient. That is why we say that it is in the form of a wave that increases with respect to time, and it's in a continuous wave. So out of its continuity, you're able to calculate and measure. Now, when it comes to digital signals, it uses zeros and ones to represent information. The zeros and one is used to determine low and high voltage in an electrical circuit, respectively. So obviously, if you are thinking about what language the computer uses, it will use this kind of signal to process information. There is electrical signal, and it represents low voltage with 0 and high voltage with 1. So this is how the computer processes information. And the computer using zeros and ones to process information, this is what we term as machine language. Now, the machine language can have a sequence of zeros and ones to represent information, and the 0 or 1 are binary numbers. They're just binary, and therefore, because they are binary, we refer to them as binary digit, or you can say binary code. And this sequence of zeros and ones can be measured too. Okay, so you can have a 0 or 1, and that is just bit. 8 of these bits we refer to it as byte. Okay, so if you have heard something about kilobyte, megabyte, these are actually representation of zeros and ones. So let's examine this table and look at how we can measure these binary units. Just as we said, a 0 or 1 is referred as a bit. Now, 8 of the bit, we refer to it as byte. Now, if you have 1024 byte, we say it is kilobyte, or 2 to the power 10 byte, which is referred to as kilobyte. So from there, then we will have about 1024 kilobyte. We refer to it as megabyte. Okay, megabyte. And then when you have 1024 megabyte, then we move on to gigabyte. So you may have heard of the sizes of storage, the size of storage devices. So if your pen drive is 4 gig, 8 gig, or you have a hard drive and then the size is 1 terabyte, then it means you actually can store up to 1024 gigabyte of zeros and ones. That's actually huge. That means you can copy a lot more information, movie, video, any kind of media. You can copy and then put it on it. Yes. So from there, then you can look at if you have 1024 terabyte, that is petabyte. 1024 petabytes would be exabytes, and then 1024 exabyte, then call that one zettabyte. So when you see a storage device that is being measured by KB or file, they are actually representation of the zeros and ones. They are, in fact, they are binaries. You will see them the actual representation in memory, and therefore they all have sizes. And you say the unit of the measurements. You see KB, so you have a file with kilobyte. You have if you snap a picture on your phone, you have maybe 3.5 megabyte. If you're using a higher res phone, then you're going to get about 5 megabyte and above, and you have these symbols attached to it. Every character on the computer keyboard have been encoded and given a sequence of bits, with each one being unique. And the one that's popularly used is the ASCII. We will look at it shortly.